So for this problem, we're trying to find the absolute minimum and absolute maximum of a function 2x cubed minus 3x squared minus 12x on the closed interval of 0 to 3. So the first step in finding the absolute minimum and maximum is finding the critical points of the function. And to find the critical points, are points that have the potential to be either minimum or maximum. And to find the critical points, we have to find the derivative of the function, set it equal to 0, and solve for x. So the first step is to find the derivative of this function. So we'll use the power rule to find the derivative. So the power rule states that we would take the exponent and multiply it by the coefficient, and then the new exponent is the previous exponent minus 1. So f prime of x would be equal to 2 times 3, so 6x, and then 3 minus 1 squared. And we'll do the same thing for the next term and get minus 6x and minus 12. So the derivative of the function is 6x squared minus 6x minus 12. And we have to set that equal to 0 and then solve. So we can factor out a 6. We get 6 minus x squared minus x minus 2 is equal to 0. And we can simplify that to 6 times x minus 2 times x plus 1 is equal to 0. And if we look at this, we can see that the 2 points where that would make this function equal to 0 would be x is equal to 2 and x is equal to negative 1. So that means that the critical points of the original function are x is equal to 2 and x is equal to negative 1. So those are the points that have a potential for being the absolute minimum or absolute maximum. So since we're trying to find the absolute minimum or maximum, we have to take into consideration the endpoints or the domain of the function. So instead of doing the first derivative test and checking the sign of the derivative at different intervals, we're going to create a table of x values and y values and use the 2 critical points as well as the 2 endpoints of the function. And we'll test those to find the absolute minimum and maximum. So to create our table, we'll just start with x and f of x. And so we're going to start with negative 1 since that's our first critical point and plug that into the original function. And that is equal to 7. And then we're going to plug in our first endpoint, which was 0, and plug that into the original function. And that will be equal to 0. And then we're going to plug in our second critical point, which is 2, and substitute that into the original function. And that is equal to negative 20. And then finally, we'll plug in our last endpoint into the function. And the result is equal to negative 9. So we can tell, just based off of these values, that the highest value is 7 at negative 1. So we know that this is our absolute max. And our lowest value is at 2. So that's our absolute minimum. And so now we know that the absolute maximum is at the point negative 1, 7, and the absolute minimum is at the point 2, negative 20.